Grade 10 Finance, Timelines, case number 2, when the interest rate changes. It is a very simple application of the compound interest formula. The only difference between case number 1 and case number 2 is that in case number 1, you do a lot of addition. When you latch on a new amount, as in a new deposit or a new withdrawal, that new amount is represented by the addition of a further compound interest formula. Another thing to note about case 1 is that the number of years that specific deposit or withdrawal spends in the account, that number is represented as the exponent, the number of years in total. However, for case 2, when your interest rate changes, your exponent is the number of years a certain amount spends with a specific interest rate. What on earth do I mean? Let me show you by means of an example. If Paul invests 5,000 Rand in a bank for a period of 6 years at 6.5% interest compounded annually for the first 2 years, and then 7.2% interest compounded annually for the remaining period, calculate how much his investment is worth after 6 years. So that number 6 years should tell you to set up a timeline starting from the present, so 0, no time has passed just yet, all the way to term 1 year has passed, term 2 years have passed, term 3 years have passed, all the way up until 6 years have passed at term 6. We can now allocate a few colors to the amounts that we are given. 5,000 Rand can be green, and it shows you that 5,000 Rand is affected by a 6.5% interest rate for how many years? For the first 2 years. It's very important to precisely mark where the interest rate changes on your timeline. So I've done this by applying that green rectangle over the T1 and T2. The first 2 years, the interest rate was 6.5%. Then, no withdrawal or deposit is made. The interest rate merely changes to 7.2%. So I put a nice rectangle around the remaining 4 years over which that interest rate changes. Once again, we're dealing with compound interest, but we may apply this formula more than once. Instead of adding and subtracting now, we merely latch on a new formula after a multiplication sign. 5,000 Rand is represented by this green rectangle, and this 5,000 Rand grows for 2 years, hence our N is 2, but that 2 does not correspond with the total amount of time that 5,000 was in the account for. That number 2 corresponds with 6.5% interest. Hence, 1 plus 0.065 is raised to the power of 2 because 2 years had a 6.5% interest rate. Then you are more than welcome to press equal on your calculator and get that answer and write down that answer at term number 2. Then you must realize that that answer now experiences another 4 years. It exists for another 4 years in the account because to get from T2 to T6 you go through 4 years, but the interest rate changes. So that answer which one attains from the green rectangle is multiplied by 1 plus 0.072 because that represents 7.2% interest, and now the exponent is 4. So once again, and that will give you the answer of 7,489.42. You can put that line in your calculator in one shot. Just to be safe, perhaps put a time sign in between the two brackets. Just to reiterate, that green amount, 5,000 Rand after 2 years, actually represents your new p-value in the compound interest formula, and then that p-value is multiplied by the yellow rectangle, which is the rectangle that represents 7.2% interest for the next 4 years. So let's practice this again. However, now we're dealing with a question that presents us with 3 interest rates. So, Thabo invested 1,200 Rand for 9 years in total. How much will his investment be worth if the interest is 6.9% compounded annually for the first 3 years, then 7.2% for the next 4 years, and then 12% for the last 2 years? If you add 3 years, 4 years, and 2 years together, you'll see that it does indeed make a total of 9 years. So 1,200 Rand at 6.9% for the first 2 years. This is slightly different from example number 1, where the change of interest rate is just represented by a vertical line, which is perfectly fine. I'll still match up my calculations to their respective colors. Then 7.2% represented 4 years of the 4 years of the investment. 6.9 represented 3 years. 7.2% was given for the next 4 years, and then the last 2 years was the purple 12%. We apply our compound interest formula, and we just latch on the change of interest rates by means of multiplying. So the red section of time, the red interest rate, 0.069, was applied for 3 years. That's why 1,200 is multiplied by the bracket raised to the power of 3. Then that answer can be multiplied by a bracket with the new interest rate, 0.072, raised to the power of 4. And then that answer that you get, the culmination of the red and the green, both of them produce an answer, and then that answer is the new P in the compound interest formula. But this new P will have an interest rate of 0.12, and the number of years that correlates to that interest rate is the number 2. If you can write all of that down and whip out your calculator, you'll get a final answer of 2,428. Please feel free to re-watch the first video explaining case 1. Watch the video explaining case 2. Take down notes and note the difference. Case number 1, the interest rates never changed. What did change was the monetary figures. Deposits and withdrawals. Deposits and withdrawals are noted by separate terms, by adding and subtracting. But if you have one figure, as in case 2, one monetary amount that stays in the account and the interest rate changes, these changing interest rates are represented by multiplying by new brackets with their corresponding interest rates according to how many years that interest rate was effective for. Please reach out if you have any questions, and good luck for your homework.